let's work on equations of lines and planes. I think last time we pretty much covered equations of lines, but let's just give you a little brief summary. All you need to find the equation of a line is any point on the line, we'll call it P, and its coordinates are going to be x1, y1, z1, and a direction vector, which we typically call v, and it's got components a, b, and c. And provided you can come up with those two things, you are pretty much ready to get the equation of a vector. There are lots of different ways to write the equation of a vector, but x1 plus at, y1 plus bt, and z1 plus ct would be one of those ways to do it. Okay, so let's look at questions where we already know the equation of the line and we want to find something else out about that line, right? So suppose I have a line and its equation is 4 plus 2t, 3 take away t, and 5t plus 10, right? For example, right? And can we imagine that that's what my line looks like, right? And I'm not going to do it for time, but couldn't I go into that piece of software and after 5 minutes of zooming out, you could see the darn thing, right? So you could visualize it and whatever. But let's look at what does that look like? Not so much what does it look like, but where does it hit the XY plane? Right. So the question is, what's the coordinates of the point where this line here crosses the XY plane? So how are we going to find that out? That's the question. How are you going to use the equation of this line to find the coordinates of the point where it hits the floor, right? The XY plane.
Well, on the XY plane, all the Z coordinates are 0. So I'm thinking solve the Z component of that for 0 to get T, and then just plug that into the other ones to get the full coordinate set.
And 4 lots, 2 lots of -2. No, God, I should have started that further over here, right? Now, what you said is exactly correct. So we've got 4 lots of 2 lots of -2. Here we've got 3 take away -2. Here we already know the answer is 0. And so you get 0, 5, 0. Now, this is called a position vector, right? It's not vector notation, but a position vector just means the vector that you would get if you joined this point to the origin. So won't that translate into the coordinates 0, 5, 0? So that guy there would be 0, 5, 0. Now, if I asked you to do not the XY plane, but say the YZ plane or the XZ plane, wouldn't you do a similar thing? You would make this guy 0, you would make that guy 0, or this guy 0. So that's how you would solve the problem of where does a line intersect a plane? Does that seem straightforward? Suppose I asked you a question. Let's see if I can find some, because it's better if I use theirs, because then the numbers will probably come out better. There should be a line meeting up with a surface. That would be nice. Is there a line meeting up with a surface? No, okay, well, let me do one. Suppose we had R of t and it was 1 take away 2t, 3t, and 1 plus t, right? So there's my straight line. And I have a surface, x squared plus y squared plus z squared equals 10, right? And the question this time is, oh, do you recognize that as a stair? Now, this line, hopefully, and I might have to change that number if it doesn't work. Can you imagine what's going to happen when a line hits a plane? Won't it enter one side and pass out through the other? So won't the chances be there are going to be two answers, right? Right, it hits the surface, passes through, and then pokes the other side, right? Like a really, really fast fundamental particle zooming through the Earth. A couple of weeks ago, I saw a really scary science program that was talking about, on Earth, what are they talking about? I can't remember what the particle, I'll call it muon, but I think it wasn't. That there are particles in space that are traveling right through the Earth as we speak. We think of matter as being solid, but matter is 99.9% ain't there, right? It gives the impression. So if you get a really fast, small particle, it can zoom right through the Earth and not even make a dent. And you might say, well, why is that scary? Well, it's also, right now, Victoria, there's some of these particles zooming right through you, right? Popping in through the top of your head, right through your entire body, popping out at the bottom, and then going through the Earth after that. Is that not scary?
No, because if it managed to get through me, it didn't interact with me, so it couldn't have harmed me.
Well, that's a comforting thought. So let's find out what happened to this one.
This is actually why reactor shielding and radiation shielding is lead. Lead is super dense. There's a lot of stuff in the way.
So it hits
of actually hitting
more than
gets
through it. Right.
Well, that's for like gamma rays and gamma rays
Gamma
won't
neutron
get,
radiation, yeah.
yeah, but they won't get through the Earth. They only get a certain amount of the rock. The ones that get to the Earth are called neutrinos, and they don't interact.
There we are. Say that name again, Will.
Neutrinos.
Neutrinos, that's the bloody stuff that zooms through you, or everything else for that matter.
Although, Tim, reactors do make a whole bunch of neutrinos, and so, I mean, they don't harm anything, so it's not really an issue, but something that my dad used to do would be when they turned on, well, not turn on, but when the reactor was running, because he worked at the shipyard, they would sit with his buddies and calculate how many neutrinos are going through their thumbs based on the power of the reactor.
Okay, that's a pleasant thought.
They're harmless.
Of this.
Never had that much time in the reactor to like worry about it, but yeah. I mean, I've thought about the amount of radiation, like, ooh, this is a lot of X-rays.
Okay, back to our question. How are you going to find out where this line meets up with the surface? I need a strategy
That
for
the
solving.
two equations equal to each other?
Could be. How are you going to make that happen?
Well, we could solve for y, because we know y is going to be 1/3. Y is going to be
No. I see where you're going. Not a good idea. But I see where you're going. It makes sense, but it's not the way you should probably try it.
You just plug it in.
Yeah, you just plug it in, which is connected to what you're saying, Tim. But I would plug it in. That can be X, that can be Y, and that can be Z. So won't we have 1 take away 2t squared plus 3t squared plus 1 plus t squared equals 0? I'm not finishing this off because I made these numbers up, so they're going to be horrible. But would you agree that would just be a quadratic?
Equals 0 or 10?
10. So would you agree this would be a quadratic? And if it's a quadratic, aren't they, can't you solve it? And 1.2, and let's just pretend that the answer was 1 and 3. I know it's not, but let's pretend it was. If it was 1, don't you go up here and replace t by 1 to get the coordinates of the first point? And then t equals 3 to get the other one. I'll call them P and Q. So if it was 1, it would be -1, 3, and 2. That would be the first one. And if it was 3, it would be 1 to equal, it would be -5, 9, and 4. And that's how you would get the coordinates. So I'm really just giving you the process, right, without getting into too much details. Couldn't you find where a line crosses any surface? Right. Okay. What about a line 1 minus t, 2t plus 1, 3t minus 5. There's a line. 2x plus y plus z equals 0. There's a plane. How would you find where a line intersects a plane?
Plug it in, just like
Yeah.
we did before.
Pretty much the same way. I'll actually do this one because it's pretty easy to do. You get this guy, and this guy. And there's no significance to this being 0. Couldn't this be 42 and it'd still be a plane, right? So don't pay much attention to that. It's just the numbers I chose. So 2 take away 2t, 2t plus 1, and 3t take away 5 equals 0. And they cancel, and 1, 2, 3. So you get 3t take away 2 is 0. And so the t value is just one number, which makes sense. Would you agree that a plane would only, if it hits a plane, you know, a line hits a plane, won't it only hit it in one place if it does? And so now that you know that that's 2/3, you can plug it into here, and 1 take away 2/3, 4/3 add 3 more, and 6/3 take away 15. Ooh, that's not nice. -3. Okay, it's not as bad as I thought. So the coordinates of that point would be at 1/3, 7/3, -3. So far, so good. Now, let's talk a little bit more about lines interacting with planes. The most common way that they're going to interact, would you agree, is that they just intersect at one point, P, in this case, that guy there. But couldn't the line be parallel to the plane? And if it was parallel to the plane, we wouldn't know that until we tried this calculation. And you would say, well, what would this calculation look like, right? How would this work out? How would the equation of the plane, when you plug x, y, and z into it, what would it look like in this situation? And this is what it would look like. This stuff here would be 47, and it wouldn't be 0. Would you agree that all of these cancel out and you just get a number like 47? And in this case, it's 0, right? So 47 equals 0. And 47 equals 0 is definitely wrong, correct? Agreed? And how do you interpret wrong? You interpret wrong as the line never actually gets to the plane, right? It never makes it. There's no t values that it would ever work for. And so you're talking about parallel. Now, what would happen in the third possibility where the line is embedded in the plane? Well, you'd still solve it the same way. Agreed? Still solve it the same way. What do you think would happen at the kind of line here where we start collecting all the terms and cancelling things out? What do you think would happen in this question?
You'd get 0 equals 0.
Agreed. Or if this was 10, you get 10 equals 10, right? If this is 42, you get 42 equals 42. And when that happens, it's always true. Agreed? And that means embedded. So do you see that that technique of substituting the x, y's, and z's into the equation of the plane allow you to tell all 3 possible things that could happen, right? You get a t value, which means you get a point. You get a number equals the other number. They're not the same, so that's parallel. You get the same 2 numbers, that means they're embedded. Okay, So what else we got to play about with? Oh, right. Well, that's how lines interact with planes. This is more difficult, much more algebraic. Lines interacting with other lines. So how do two lines interact with each other? Let's do some color schemes. If two lines meet or intersect, would you agree that the logic is, if that happens, isn't there only one point of intersection? Right, in 3D space, if two lines crash into each other, they're only going to crash into each other in one place. Couldn't two lines never meet? So the two lines are essentially parallel. Wouldn't that be another possible interaction between two lines? Agreed? And the one that I actually drew pretty good last time, I don't know if I'm going to get the same here. Couldn't the two lines be skewed? So they never intersect each other, but they're not parallel either, right? So that's parallel and that's skewed. I guess I should put in the names. So here's parallel. Here's skewed. Here's intersect. And the last one, I'm only putting in for completeness. Couldn't both lines be the same? And we know that that can happen because aren't the equations of lines not unique? So it's quite easy to have two lines that are the same line, but you don't notice they're the same line because their equations look different from each other. So that could happen. So we have some possible interactions here. And I guess the question is, how do we do them? Right? So let's suppose I have line 1 and line 2, and we'll do it as a parametric equation. So I'm using the guys that I can see right now. So this is question 16. And it's going to be x equals 12 plus 8t. And the y is going to be 16 take away 4t. And the z is going to be 4 plus 12t. And then the second line, oh, let's do a different color. X is going to be 1 plus and 4s. And y is going to be 3 take away 2s. And lastly, z is going to be 4 plus 5s. I put little things on my s's because they look awfully like 5s if I don't put little funny things on my s's. When you are looking at the interaction of two lines, you must make each line have its own dummy variable, right? And t and s. If you make both of them t, what you're saying in reality is that these two lines work on the same time scale. T is basically where you are at time t on the object. And so it's good math to not make that assumption, so give them different letters. So we are going to try and come up with a technique that allows us to figure out which one of these 4 questions or 4 situations we're going to deal with. So I'm going to start with testing for parallel. What you do here is for line L1, you pull out its direction vector, and for line 2, you pull out its direction vector. Now we know how you do direction vectors. Would you agree this one is 8, -4, 12? And would you agree this one is 4, -2, 5? Are we comfortable with from the equation, and this is parametric form, from the equation of two lines, can you pull out the direction vectors that were used to create them? We're good with that. Now, how's that going to help me test for parallel? If two lines are parallel, does it not make their direction vectors parallel? And if two vectors are parallel, won't one of them be a multiple of the other? Like one of them is 2 times the other one, right? So let's test for that. And the way you test is divide corresponding components. And this is 2, and this is 2, but that ain't. That means these are not parallel. Now, if this last number here, the one that says 12, if this had been 10, can we pretend for a minute it was 10? Wouldn't you get 2, 2, and 2? Wouldn't that mean these two lines are parallel? You've nailed it. Because you can't be, you can only be one of these things at the same time. Can we pretend identical is a special case and we'll ignore that? But I'll show you how you would do it if you want to, right? Are you happy about it's not parallel? Now we need to move on to, okay, we've still got intersection, skewed, or identical, right? We've still got those guys. Although now that I've thought about it, can I also kick out identical? Because if you're identical, wouldn't you also be parallel at the same time, right? So we're now left with only the intersect or the skewed, right? That's all we need to figure out. Any suggestions how you might tackle that problem? How you might find the point where they intersect, if they do intersect.
Set them equal to each other on a part per part basis.
Nailed it, exactly. But what we're going to do is only match the x's. So that's this guy is equal to that fella. That's the x's, right? Match the y's. So that's 16 take away 4t. No, I don't want to do that. I'm going to x and the z's. And that means I'm going to match 4 plus 12t and 4 plus 5s. And you might think, why did he change your mind? Why did he just not do x and y? You remember these guys being multiples, the same multiple? If I'd done x's and y's, can you trust me, the thing would have probably mathematically, the t's would have disappeared on me and I would have had problem solving. Right, just trust me on that, right? So pick one of these and one of them, right? Pick two different guys, right? So if you get 3, 5, and 7, pick any two you like. But if you get 3, 3, and 7, pick one of these and the 7 guy. Right. So this is equation 1 and this is equation 2. Do you recognize a Math 99 problem which is solving a system of equations? Right. 2 unknowns, 2 variables. They don't look very pretty, so let's move them around a little bit. How about subtracting 4s from both sides? So that's 8t take away 4s. And while I'm at it, subtract 12 from both sides. So that's my new equation 1. And this one, I'm going to have 12t take away 5s. And, oh, I get 0. It's a little bit nicer. So, there. Does it look more like a system of equations to you now? Okay, this one's going to test your memory. How do you solve system of equations? What do I do?
Solve for one of the variables.
Okay, so you want to do what's called the substitution method then, right? And nothing wrong with it. Perfectly happy with it. What's the other method?
Set them equal to each other. Like if you added 11.
Oh, interesting thought. I don't think that would work, but I like the thinking. The addition method is the other method. That might be what you're kind of thinking of. What? Right. Now, if you want to do the addition method, don't you have to have the same number of each variable, but one plus and one minus? Would you agree that's probably going to be quite hard in this particular question? So let's do the elimination method. Which equation do you want me to use as my starting, 1 or 2? It really doesn't matter to me, but just so we could do the process.
1.
Okay, so I'm going to take equation 1. And I'm going to find what t is equal to. So I'm going to add 4s to both sides. And then I'm going to divide everybody by 8. Not very pretty, but it'll do, right? I'm then going to put t equals 1/2 s, take away 11/8, and I'm going to put it into this equation here. Let's go back to black. So what do I have? I have 12 lots of this guy. Take away 5s equals 0. 12 lots of that guy gets me 6s. 12 lots of that guy, oh God, that's 4, 4. That gives me 2 in the bottom. 3, that gives me 33 halves. Take away 5s. So we end up with this looking line, and s is 33 halves. Are you comfortable with the, oh good, I didn't screw up in the numbers. So s is 33 halves. How will I find who t is? Right, you got 1. How do you find t?
Just plug s back into it.
Right, so it's going to be 1/2 of 33 halves, take away 11/8. T is going to be 33 quarters, take away 11/8. That's going to be 66/8, take away that, that's 55/8. Oops, I better keep them because I need them. Just rewrite them down. Line L1 is this guy, and that guy. And line L2 is this guy, and finally this guy. And I know that S is 33 halves, and I know that T is 55/8. So far, so good. Now, I'm going to plug 33 halves into all 3 of these guys. I'm going to plug 55/8 into all 3 of these guys. If this guy here is the same coordinates of this point here, doesn't that mean that they intersect? Right? So if the coordinates of L1 and the coordinates of L2 are the same when you use these numbers, that means that the 2 lines intersect at that point. Suppose the first 2 are the same number, but this is 10 and this is 5. Then what does that mean? That means that they are skewed. Okay, so a single point, they intersect. If they differ, it's skewed. So X is going to be 12 plus 8 times 55/8. The Y coordinate.
So,
Question.
is there any way to tell that they're skewed before you plug it in?
I'd be interested if you think you can tell me. I can't see one, but I'm always,
Okay. I was just thinking if you're solving for them being equal to each other and you found like an S value and a T
oh,
value.
I know what you're getting at, and I can agree with you. Do you know these two are guaranteed to be right equal? So don't I really only need to test the Z? Now you might say, why are these two guaranteed to be equal? Oops, I apologize. Aren't these going to be equal? Because we used, right, remember the equations we use. So I guess if I wanted to save time, and that does make sense, couldn't I just check the middle one? So, and here goes then. The Y coordinate is 16, take away 4 times 55/8. So that's 16, take away 55 halves. That's 32, take away 55, it's 23 halves. Okay, that's that one. Let's do it for the other one. 3, take away 2 lots of 33 halves. That's 3, take away 33. That is negative 30. Hey, let's stop. Would you agree that the Y coordinates don't match? And if they don't match, what situation do we have?
They don't intersect.
They don't intersect, so we are looking at skewed. Whew, that's a lot of work, isn't it? So I'm not doing any more of them. But won't you do every single one of the questions the same way? You'll test for parallel first. If they're parallel, great, question's finished, right? If they're not parallel, they won't be identical. So you then move on to pick 2 of the equations, set them equal to each other and solve. And then whatever the solution is, match it against the one you haven't used, in this case, the middle one. And if they match, they intersect. And if they don't match, they are skewed. So the last guy is, how does identical work? So let's suppose we found out that the lines were parallel, but we didn't know whether it was parallel because they were parallel and they never meet, or they were parallel because they were identical, right? And you might say, well, how on earth can you check between those 2 situations? Well, here's our equation. Can we pretend for a minute that these are parallel, right? Just for argument's sake. All you need to do is find a point, right? So you know that the lines are parallel, right? And you want to find a point that works. Well, when you do this, technique here, the system of equations, you won't be able to solve the equation. That will happen. And why does that happen? It happens because the lines are identical. So when you're doing the system of equations and you're trying to find out, do the lines intersect or not? And you get 0 equals 0 coming through, right? As we did here. 0 equals 0 is essentially telling you that it works all the time. So you're looking at identical. So you try X and Y, you get 0, 0. You try X and Z and you get 0, 0. So that's one strategy. A second strategy, a little bit different. Couldn't I just plug T equals 0 and T equals 1 and find 2 points on this line? And then if I found out that the same 2 points were in that line, wouldn't that make the lines identical? Does that logic work better for your brain?
I do have one question on that.
Yes,
So
Lauren.
if the lines are identical, are
Mhm.
S and T the same then?
If the lines are identical, and what did you do to finish?
Are S and T the same?
No. You could get an X coordinate equal at different places. For this one's hard to do, but can you imagine T equals 3 gets you 12, and s equals 4 gets you 12. You see the t and the s would be different numbers, but the x's would be 12 at those two different points. That's the reason they're not equal to each other. What will happen is that when you try and solve the system with equations, all the s's and t's disappear and you're left with 0 equals 0. That's what the algebra would look like. A good, interesting question. Are we done? Okay, we have done everything that we need to worry about with lines. We have got to do planes now, or at least get started on them. How to find the equation of a plane?
That was a really good outline.
What was that again, Tim?
I said that was a great outline.
Okay, here goes. Do some theory. You know, a plane is a flat piece of paper, right? It's orientated at some angle and it's in 3D space and it goes everywhere. You know that I've already told you that equations of planes look like this, right? They're a linear combination of x, y, and z. So pretty much the question is, well, how do we find this equation? Well, maybe not the way you thought. Imagine that's a plane in 3D space. There is a very special vector that a plane has. And it's this vector here. And it very often is called n. And its name is the normal vector. If you want its full title, it's the normal vector of the plane. Now, what's special about this vector? Well, if I bring my little piece of paper back out, this pen is what the normal looks like. It has the property that no matter what line you draw, it's always perpendicular to the plane. So you can imagine a vector perpendicular, orthogonal is a better word, to a plane. Imagine that. That guy has components A, B, C. The equation of this plane will be AX plus BY plus CZ equals a number. Do you notice how you can get the coefficients of A, B, and C by knowing what the normal vector of the plane is? So there are two pieces of information that you need to find the equation of a plane. And these are the same two things you always go looking for. So to find the equation of a plane, you need to know, one, any point on the plane, doesn't matter which one it is. We're going to call that point x1, y1, z1 again. And the second thing you need to know is the normal vector. And if you know those two things, the equation of the plane will be AX plus BY plus CZ equals AX1 plus BY1 plus CZ1. So far, so good. I've given you a formula for getting the equation of a plane where you know the coordinates of a point and you're told the normal. So for instance, if I tell you that a plane passes through the point 1, 2, -3, and that its normal vector is 5, 1, 2, then the equation of the plane that passes through this point with that normal vector will be 5x plus a y plus 2z equals 5 times 1 plus 1 times 2 plus 2 times -3. So it would be 5x plus y plus 2z equals 5, 6. Oh, 7. Yeah, nice number, 1. So this is the generic equation of a plane, right? That's what all planes end up looking like. Would you agree this is magic? I'm just telling you this is the formula and you're going to trust me. So let's prove it to you. So imagine I've got a plane and here is the point P with coordinates x1, y1, z1. Here is the normal vector, A, B, C. And here is a random point, I'm going to call it Q, on the plane. So any point on the plane, would you agree it would just be X, Y, Z because it's represent any point on the plane? I'm now going to join that point to P. What do you know about that angle? You're nodding. What do you know about that angle? What is
90
it?
degrees.
It's 90 degrees. Now, if you take the
Or it's
vector
1/2
P,
pi.
well, I like 90 degrees. So PQ is this vector, right? And isn't this other one just N? So PQ is going to be X take away X1, comma, Y take away Y1, comma, Z take away, Z1. And the normal vector is A, B, C. So far, so good. And since they are orthogonal, 90 degrees, won't the dot product be 0? And if you take the vector A, B, C, and you do it with the dot product of this guy, you get, equals 0, you get A lots of x minus x1 plus B lots of y take away y1 plus C lots of z take away z1 equals 0. And that's AX take away AX1 and BY take away BY1 and CZ take away CZ1, and that's equal to 0. And if we leave the AX and the BY and the CZ here, by add that, and add that to both sides, bingo, don't we get the equation of a plane? Yeah, that wasn't, I think that's pretty intuitive. You agree it's not the weirdest proof in the world, right? So any point in a plane, right? The general equation is AX plus BY plus CZ equals that. So just to finish with, let's give you a really baby question. What's the equation of a plane that passes through the point 1, 2, -7 and has a normal vector 1, 1, 3? And the answer will be 1x plus 1y plus 3z, right? Basically, there's ABC. And then 1 times 1 plus 1 times 2 plus 3 times -7. And that's 3 and 21, so that's -18. That's how easy it is to find the equation of a plane if you tell me the point and the norm. You agree that's pretty straightforward now that you've got it. So what they're going to do tomorrow? We are going to give you information that will allow you to get the equation of the plane, but most of them won't be this nice information, right? A 2-liner. they're going to tell you the point. A lot of the times they tell you that point, but not always. And then they'll say things like it's parallel to this other plane, or it's perpendicular to these two lines, or it's blah, blah, blah. And the blah, blah, blah bit is going to involve you trying to figure out what n is from the information in the blah, blah, blah bit, right? So there's all sorts of things that they could give you that eventually you are going to be hunting for this. So always think about, I need to find this guy, right? Occasionally, you're also going to have the even more difficult problem of finding this point. Right. And say hi and bye-bye. Well, actually, don't say hi. Say your last name and bye-bye.